So I'm going to do number 2 and number 10 on the practice 4 test, so you can get ready for the proctored version. Number 10 is actually really easy, so let's do that one first. Now that you've... Oh, shoot. Go away. Go away. This one? I guess my screen's not big enough to show everything. Okay, so it's an earthquake problem, and it's a little bit different than the one that you've seen in the book. So the Richter scale is a numerical scale for expressing the magnitude of an earthquake on the basis of seismograph oscillations. The difference in Richter scale magnitudes can be determined by using that equation, where m1 minus m2 is the difference in earthquake magnitudes, and I sub 1 over I sub 2 is the ratio of the earthquake intensities. These are just problems that college professors grab onto, and they say, oh, how cool is this? And they throw it out there, and it doesn't make any sense to you, and you learn how to solve it, and then life goes on, and you forget about it. Okay? But we got to learn it. So what this is saying is, if you know how strong one earthquake is, and how strong a second earthquake is, then you can use this formula to find the difference between their magnitudes. So if you have a super strong earthquake, and then later you have an aftershock that is not as strong, you can use those two numbers to find the difference in the magnitudes between the first and the second, even without knowing the magnitude of the first and the magnitude of the second. Now, that's not what we're going to do in this problem, because so this is the magnitude of the first earthquake and the magnitude of the second earthquake. But in this problem, they tell us the first earthquake had this magnitude, and then instead of telling us the energy from both earthquakes, it just says that the first earthquake, the aftershock was 75 times less intensive than the original quake. So we do not know how much energy was in the first earthquake. And we do not know how much energy was in the second earthquake. But we do know that the first earthquake was 75 times more powerful than the second earthquake. Does that make sense? So this fraction is 75. Okay. Now, why is this in a logarithm chapter? I don't really know, because, well, I guess log shows up, but watch this. I know that this earthquake had a magnitude of 5.8. Minus the magnitude of earthquake number 2, and that is the log of 75. Now, how easy is it to solve that? It's super easy. I'm going to add the magnitude of 2 over here, and I'm going to subtract the log of 75. So the end result is simply 5.8 minus the log of 75. So the first earthquake was a 5.8, and then the second earthquake was 3.92 magnitude units below 5.8. So it doesn't ask, but the second earthquake would have been a 1.8, which is tiny, tiny, tiny. Okay, you probably wouldn't be able to feel that. If you did feel it, it would probably feel like a medium-sized truck driving past your house. Have you ever had a big truck drive by and your house shakes? That's like a 2 or a 3 on the Richter scale. So very, very, very faint. Okay, So that's the easy one. Number 2 is the one that's going to give us some problems. And it's not, number 2 is really weird. And I've looked at this. I've never seen anybody ask this question before. So I spent some time working on it, and I figured out 2 ways to solve it. One is really easy, but it's hard to understand. And one is a lot harder, but it's easy to do. I don't know if that makes any sense to you. So first we need to learn a little bit about exponential graphs. So if I had y equals 3, no, let's not do that. Yeah, let's do this. Y equals 3 times 2 to the x. That's going to hit the y-axis at 3. And is this a growth or a decay? Growth, because it's bigger than 1. So the graph is going to look like that. Okay. What if I change this 2 to a 3? How's that going to change the graph? It's just going to make it steeper. So it would look something like this. No, a 1 would be a flat line. Okay. All right, what if I had y equals 4 times 1/2 to the x? So it's going to hit the y-axis at 4, and it's a decay. What if it was 1/3? It's going to be more decay, right? It's going to be steeper. Okay. Well, what if I make the number out front negative? It's going to be upside down. So the growths would look like that, and the decays would look like that. All right. Now, what if instead of 3 times 2 to the x, what if it was just 2 to the x? Not 0, 0. What's the number out front? A 1. So that graph is going to hit at 1, and it will have a growth. This would be a decay, this would be a negative growth, and this would be a negative decay. Is everybody all right with those? Okay. So, which way do I want to do first? Let's do the easy way that takes more time. So, in our function here, normally we use y equals b times m to the x. But in this case, b is either going to be 1 or -1, as seen from this. Right? A is the base of the exponent, so a is our m value. And so this graph is going to hit the y-axis at 1 or -1. Kind of. All right? But they've made some changes to the equation. They have altered the x value by either adding b or subtracting b. We don't know, so we'll have to figure that out. They have also changed the y-axis by adding c or subtracting by c. Okay? So, can you tell if this graph has moved up or down from the original exponential equation? It's moved up. How far? Yeah, you have to look at the asymptote. So normally, every exponential equation approaches 0 either from the left or the right. So all exponential equations look like this. And you'll notice that on one side or the other, we are getting closer and closer to 0. Okay? So this graph has been bumped up 2. So that tells me that this number is +2. Does that make sense? So in that grand equation, y equals plus or minus a, x plus or minus b, plus or minus c, I know that this is +2. Okay? So y equals plus or minus a, x plus or minus b, plus 2. Does everybody understand where the 2 came from? So let's now remove the 2 from the graph and see what happens. So I'm going to draw a new coordinate system right here. Right? So this 6 is really a 4, and the 4 is really a 2. What's happening to my decay? How fast is it decaying for every 1 unit of x? So we started at 4, and 1 week later we're at 2, and 1 week later we're at 1, and 1 week later we're at 1/2. I'm multiplying by 1/2 every time. Okay? So A is 1/2. Is this a positive exponential equation or a negative exponential equation? Positive because it's above the x-axis. Okay, so I have just figured out a whole bunch of things. I figured out C, I figured out A, I figured out the plus or minus. So I now know that y is equal to positive, and really it's a 1, times 1/2, but we don't need that, right? So 1/2 to the x plus or minus b plus 2. Does everybody understand it so far? So I looked at the graph to figure out my c value, which was up 2. Okay? I redrew the coordinate grid so that I could figure out my a value. And we know this is a decay. How fast is it decaying? 1/2. And then I know the graph is above the x-axis, which means it's positive. How am I going to figure out b? That's the only thing I don't know. Well, I have an equation with 3 variables. Is there a way to figure out 2 of those variables so I can solve for the third? I know a bunch of x's and y's, right? So plug in a point. Does it matter which point? No, doesn't matter. So I'm going to put 4 in there and 1 in there. So 4 is equal to 1/2 times 1 plus b plus 2. Solve for b, subtract 2. 2 is equal to 1/2 raised to the 1 plus b. ln both sides. So I get the ln of 2 is equal to 1 plus b times the ln of 1/2. Yeah, but it'll just tell us, right? When we solve it, we'll either figure out that b is positive or negative. So yeah, technically it's plus or minus b. We don't know which one, but we're about to find out. How do I solve this? Divide by the ln of 1/2. Divide by the ln of 1/2. So the ln of 2 over the ln of 0.5 is 1 plus b. So I need to figure out what this is. The ln of 2 divided by the ln of 0.5 is -1. So -1 equals 1 plus b. So b must be -2. So that's a lot of work to figure out that the equation is y equals 0.5 times x minus 2 plus 2. And that method will work every time, but that was a lot of work. So I thought about it a little bit more, and I realized this is just a set of transformations. So if I had x squared, and I changed it to x squared plus 2, what happens to the graph? It goes up 2. What if I changed it to x minus 3 squared? It goes right 3. How come? the inside, the x's go backwards. The y's work the way they're supposed to, and the x's go backwards. So if I can figure out what the original graph looked like and count the transformation, then I can solve all of this without logarithms. So we know that it's plus 2. That's the easy part. So y equals, once I figure out it's plus 2, then I redraw that coordinate plane, and I know that my a is 1/2. So 1/2, okay, hold on, let's do it a little bit differently. So I redraw my coordinate plane, and I know that c is 2. Well, what is the y-intercept right here once I redraw my coordinate plane? 4. And what's my multiplication, my base value? Divide by 2. So times 1/2. So I know the equation is 4 times 1/2 to the x. That is this equation right there. Right? Well, it tells me that this number has to be a 1. So, how many x's does it take to undo a 4 when you multiply by 1/2? Which way do I have to move the graph, left or right, to turn that 4 into a 1? Okay, so I told you this was the easy way. That's harder to understand. Here's the graph, right? I want that graph to hit my new y-axis at 1. Do I move it left or do I move it right? I have to move it left. How far? 2 times. So if I move this left 1, why isn't that working? So 1, 2. Now it hits at 1. Okay? So that was the original graph. So to take the original graph and move it and land where I am now, I have to move it right 2, which turns into an x minus 2. So basically, to convert this into a 1, to take the 4 and convert it into a 1, I have to do x minus 2, and then to lift the graph up, I need to do plus 2. Yeah, it's a lot harder to understand though. Okay, so both ways work. The original way is the one that I figured out first, but after I thought about it for a little bit, you can just use transformations. If you don't understand the transformations, that's fine. Just do the other method. Do you want to see another one? Okay. Yeah, because there is a good chance you're going to get one that's upside down, and that's going to freak you guys out. Give up. I just gave up. Okay, so hopefully we get an upside down version. Oh, darn it. Okay. Easy way first. What direction did this c value move the graph? Down 2. So I know that c is negative 2. Or, sorry, it's not 2, it's 1. So c is negative 1. I'm going to redraw my graph. Okay. Which means this 8 is actually a 7, and then 7, 5, 4, hold on, I can't count. 5, 3, 1. Okay, so how much is this graph, I really screwed that up. Let me try again. 7, 5, 3, no, 9. How about 9, 7, 5, 3, 1. Sorry, guys. Okay. So from -2, so from 2 hours ago until 1 hour ago, how much did we change? We went from 1 on the y-axis to 3 on the y-axis. So my A value is multiplied by 3. Okay? Each day is a triple of the previous day. So y is equal to, is this a positive graph or a negative graph? Positive. So it's positive 3 times x plus b minus 1. Now b might be negative. We don't know until we solve it. What's our next step? Plug in a point. Which point will be easier? -2, 0. I like that number. Or actually, this one might be easier. 8, 0. Or 0, 8. Let's do that one. So 8 in for y, 0 in for x. 8 equals 3 to the b minus 1. So we add 1. Oh, how nice. I don't even need logarithms. What's the answer? Close. 2. I knew what you meant. So the equation here is y equals 3 times x plus 2 minus 1. Okay, that's the easy way to do it. The hard way would be, okay, we're dropping down 1. So if I draw this graph here, and then I do 9, 7, 5, 3, 1, I can see that my A value is 3, right? But in this case, the graph is hitting 9. So y equals 9 times 3 to the x. And then how many 3's do I have to how many 3's do I have to do to get rid of this 9? I need 2 3's to get rid of that 9. So this 9 can be recreated by moving the graph to the right 2. And then the whole thing just comes down 1. Way simple, but that's kind of hard. Yes. So why is that not -2? Because we're going backwards, right? So where did the graph need to be so that I could move it right to and end up where I am now? So, and another way to think of it is, okay, let's do this. Okay, let's get rid of that. Okay. This is 3 times 3, right? This might make more sense. Right? So what is 3 times 3 times 3 to the x? It's the same as that. That makes a lot more sense. So 9 times 3 to the x, well, this is just 3 squared. Yeah, that's way easier. Okay, and the same thing, so when we did the 1/2s, so in the last problem, this is what we did. Can 4 be created using 1/2s? Everybody think about that. Can 4 be created using 1/2s? Yes, by using negative exponents. So 4 is 1/2 to the negative 2. So if 4 is 1/2 to the negative 2, then I can say I have 1/2 to the negative 2 times 1/2 to the x, which translates into 1/2 to the x minus 2. That makes way more sense. Yes. Okay. Get to work. Good luck.